Okay, we're gonna do these guys. It's basically what we did last week, but it might be a little bit more difficult. I don't think so, honestly. Let's see. So we're just gonna find the derivatives of these guys. Let's see if you remember. What will be the answer to A? It's an e to the power of something.
First you write itself.
Yeah, you write it itself, and then what do you multiply by? So for the first one, it's gonna be e to the minus 2x squared. Are we done?
No.
Okay, what do we multiply by?
With the exponent.
So minus 2x squared. You multiply it with the derivative of the exponent. What would that be in this case?
Negative 4x.
Yeah. And that's it for that question. Times minus 4x. What about b? B is a different function now. It's still an exponential function, but there's no more e attached to it. It's very similar. What would be the answer to b? First, you're going to write itself. Then you're going to multiply it because there's a 3 here. It's not an e. You're going to multiply by ln of that number there. Finally, you multiply it. Again, the multiplication, the order doesn't really matter. You can multiply it with the derivative first or with the ln first. What's the derivative of the exponent?
2x plus 3.
Yeah, and that's it for that question. What about the third? Third one looks a little bit weird, right? How would we approach the third one? There's multiple ways to do it. You could use the quotient rule, or because this is just a constant, right? We can just distribute this. We can rewrite this. This is not the derivative. This is just the first thing. We're going to rewrite this. We're just going to split it apart. Because when we find the derivative, we can find it one term at a time. We don't have to use the quotient rule here. What will be the derivative of the first term? The constant is going to stay. Yeah, itself. And what do you multiply this by?
3.
Yeah, that's it. Second one is also going to be very similar. Constant stays, e stays, and then you multiply it by negative 3. Because that's the derivative of negative 3x. And you are done. Easy peasy. And these ones are going to be a little bit trickier. Remember, sine becomes cos. Cos becomes negative sine. And tan becomes sec squared. So if you look at d again, it's pretty simple. You just do it one thing at a time. What would be the derivative?
Two cosine x minus 3 negative sine 5x.
Okay, are we done? Or is there more to this? You multiply it by? What's the derivative of the bracket for here? It will be times 5, yeah? This is the second chain rule component. Cosine becomes negative sine 5x. The angle's not going to change, but then you have to multiply it by the derivative of whatever you have there. What about e? What would be the answer to e?
Do you bring the 3 in the front?
Yeah, you do. Yeah. It's going to become 3 what?
Cosine squared.
Yeah, 3 cosine squared x squared. What do you multiply this by?
2x.
It's 2x, and you're done. That's it. What about f?
Could you change the square root to the power of 1 over 2?
Yeah, okay, so we can first rewrite this as tan of 1 minus, well, 1 minus x to the 1 over 2. Okay. What's the derivative?
Sec squared.
Yeah. Again, the angle is not going to change. Okay. It's going to drop down as it is. But then you need to multiply this by the derivative of that angle. What will be the derivative of the bracket in this case?
Do you bring the 1 over 2 in the front?
Yeah, you do. So you're going to first bring the 1 over 2 in the front. The power rule. Inside thing does not change. Then you take 1 away from half. You get negative 1 over 2. And then we're not done yet. We need to multiply this by something, which will be the derivative of this bracket. What's the derivative of 1 minus x?
Do you bring the negative 1 over 2 in the front, or?
So we already dealt with tan. We dealt with the square root function, yeah? But we haven't dealt with just this bit, 1 minus x, just this bit. It'll be, this is a double chain rule question. You just multiply it by negative 1 at the end. Okay, which is the derivative of 1 minus x. So it's a double chain rule.
Okay.
So you first do tan, and then you do for the square root, and then you do it for this guy. So there's multiple steps to this one. It's asking you for the equation of the tangent curve. Okay. You remember how to do this? There's 3 steps. You're gonna first find, well, you need to find y equals mx plus b. Now in this question, this one's a little bit tricky because usually they will give you an x value, but they have not given you an x value. So we kind of don't know anything in this case, but using this information, they've given us a line, okay? So what's actually going on here, the bigger picture is this. 2e to the x, 3x looks something like this. We want to find the tangent, the equation of the tangent line at some point x. We don't know where this x point is, but we know that this line is parallel to, what is this, y equals 6x plus 2. We know that this line is parallel to this line. See, like that? Now, this is a grade A question. How are parallel lines related?
They have the same slope?
They have the same slope, okay? Whatever the equation of our tangent line is, its slope is going to be m, right? This slope is going to be the same thing as the slope of our parallel line. What is the slope?
-6.
Well, that's not in the right form, right? If you write it, if you throw this to the other side, y equals 6x plus 2, it's positive 6. Okay, y equals mx plus b form. You see that? It's not -6, it's going to be positive 6. So we know our slope is positive 6, so this is done. But we don't have an x value, we don't have an y value. Remember, the slope of the tangent line is simply the derivative of our main function. Okay, add some x value. What's the derivative of y? What's y prime here? This is our y. So it's pretty simple. It's
Can
just
you
a
write
one step.
itself?
You write itself. What do you multiply that by?
3.
3. So your y prime is 6e to the 3x, okay?
Mm-hmm.
Now we know that this is our slope function, and we already know what our slope is. We're looking for the x value. In order to find the y value, this you do last because you don't know your x value. We can set this equals to this because they're both the slopes of the tangent function. And we're going to solve for x. It's easier than you think. 6e to the 3x equals 6. Divide both sides by 6. You get e to the 3x equals 1. All right, now what? Now this is an exponential equation. It's not linear, it's not quadratic. Think about what value of x would make this equation 1.
0.
0, yeah, exactly. X must be 0. So there we go, x is 0. We can plug it back in here to find the y value. Y will be 2 times e to the 0, or 3 times 0, doesn't matter. That's going to be 2. So we have our y value 2. We have our m value 6. We have our x value 0. We have our, we don't have our b. So b is going to be 2. Therefore, final answer y equals 6x plus 2, mx plus b. And that's how you do this question. Does that make sense?
Mm-hmm.
Just a quick recap of what happened. Using this line, we automatically know what our m is. Finding the derivative and setting it equals to m, we can find our x value, and we can plug it back into the main starting equation to find our y value. And this is just easy to finding the b value, just plugging and chugging. A question for you. How are perpendicular lines related? Parallel lines, they have the same slope, yeah. What about perpendicular lines? How are they related? It also has something to do with the slope. Any ideas?
Is 1 like negative?
Just negative? Just negative is not good
Like
enough.
the opposite?
Yeah, it is. So it's like it's called a negative reciprocal. Okay. For example, if one of them has a slope of 2, what you do is you flip it upside down, which is called a reciprocal, and then you put a negative sign. The slope of our other guy is going to be negative 1/2. For example, this is y equals 2x. The perpendicular line for this will be something like this. Well, it has to go through the origin, so something like this. And this one will be y equals negative 1/2x. So the slopes are going to be negative reciprocals. Okay, if m is negative 1/8, what's going to be the slope for the other guy? For a line that's perpendicular to this.
8.
8, yeah. So that's how perpendicular lines are related. Here's a physics question. The velocity is just a fancy word for speed with direction. Remember, for these physics problems, you have 3 different things. You have position. If you find the derivative of this, you're going to get velocity. And if you find the derivative of this, velocity, you're going to get the acceleration function. So they've given us the velocity function, and it's asking us to show the acceleration. All right. What will be v prime of t? Vt is given. It's an exponential function, not that difficult. What will be its derivative?
You write itself?
Yeah, you're going to write itself. What do you multiply this by?
Is negative k a constant? Or like,
Yeah, it is. Yeah, it says right here, k is a constant.
so you multiply it with t?
Ooh,
Wait, negative k?
negative k is right, yeah. Because t is our variable, right? Just look at this v of
Mhm.
t is our variable. So we can just rewrite this as, well, we know 10 e to the negative k, this guy by itself is v to the t, and then times negative k. So that's going to be your acceleration function. The derivative of the velocity is our acceleration function. So it's proportional to a constant multiple of its velocity. And that's true because this is a constant multiple. This is not going to change. And this is our velocity function. Explain what is happening to the particle. That's a little bit more difficult question, I think. It all has to do with the negative sign right here. If, this is weird, okay? If velocity is positive, you're speeding up, okay? If velocity is negative, this one is really tricky because you just expect it to be slowing down. But this velocity negative means it's just going in the opposite direction. For our frame of reference, it depends. If we say up is positive, like north is positive and east is positive, if the velocity is negative, it just means it's going left or it's going down. It doesn't mean it's slowing down.
Mhm.
Acceleration, on the other hand, if it's positive, it means it's speeding up. But if the acceleration is negative, it means it's speeding down, it's slowing down. Okay? So that's what this means. Explain what is happening to the particle. The fact that the acceleration will always be a negative number. You see this? Because this is an exponential function. This cannot be negative. This means since the acceleration is negative, it's slowing down. And that's it. Cool?
Mhm.
I can show it to you if you want, like what's actually happening. The graph of this guy, the main function, velocity function. Again, it's an exponential function. They always look like this. But there's a negative k up there. That's a reflection on the y-axis. It's just a quick transformation. So you'll get something like this. And this is a velocity function. You have velocity on the y-axis. Time is always going to be in our x-axis. You can see that the velocity is going down, right? That means it's slowing down. And we knew that because we got a negative acceleration. Cool?
Mhm.
Are these tangent line positive or negative? What's the slope of these
Negative.
Yeah, exactly. It's negative. And we saw that with the a being negative. We already knew that, but this is the graphical way of looking at it. So even if you did not know any calculus, you didn't know how to find the derivatives, this you'll do in the functions course. You can answer this. Well, you can't answer the first part, but you can answer the second part. It's slowing down. All right, what's the initial velocity of the particle? Initial velocity means at time zero, what's the velocity? You just need to find v of 0. So that'll be 10 e to the negative k is a constant, but time is 0. What is this going to be? First of all, what's negative k times 0?
0.
0. So you have t e to the 0. We know e to the 0 is a 1. Yeah. So
Mhm.
it's 10. 10, what's the unit? Centimeters per second. There you go. The initial velocity is a 10 centimeters per second. That's the answer to B. C, at what time is the velocity equals to half of the initial velocity? So the velocity is halved. What is it going to be in this case?
5.
5. So you have 5 is equals to 10 e to the negative kt. Hmm. I think the answer is going to be in terms of k. It doesn't matter. Next, divide both sides by 10. You get 0.5 is equals to e to the negative kt. Now from here, it's a little bit more difficult. How do you solve this equation for t? The 0 thing doesn't work because you don't have a 1 on the other side. You need to bring the exponents down. Do you remember how to bring the exponents down?
Do you use log?
Yeah, you would use logs, but because there's an e function here, the natural log function, instead of using logs, you'll use ln, ln, which means the natural logs. So log you'll use if it's not e, basically, for any number, like 2 to the power of x or something, you'd use logs. But if it's e, you want to use ln. So the rules are the same. Ln 0.5 is equals to ln of e to the negative kt. If you use a ln for an exponential function, the exponent drops. So you get ln of 0.5 is equals to negative kt times ln of e. Ln of e is a 1. So this goes away. So therefore the time is going to be ln of 0.5 over negative k. Cool?
Mm-hmm.
And the second part, it says, what is the acceleration at this time? Well, we know our acceleration function is the derivative of the velocity function, which was negative k times 10 to the e times negative k times t. This was the derivative of this. And to find the acceleration at this time, you just plug this time in there. So you get negative k times 10 e to the negative k times ln of 0.5 over negative k. Do these two negative k's cancel out? This one and this one, can we cancel these out?
Yes.
Yes, you can. This is gone with this. E to the ln of 0.5. The funny thing about e is that this e is going to cancel out with this ln as well. And then the 0.5 is going to drop down to this level. So you get negative k times 10 times 0.5. So the answer is negative 5k. The acceleration is negative 5k. Cool?
Mm-hmm.
Basically, this cancels out because these two are inverse functions. Another thing is like this, 10 to the log x. 10 and log is going to cancel out. X is going to come down here. Same thing here. This is going to come down here. You can also have log to the 10x. Same thing. These two are inverse functions. They cancel out. You're just left with an x. Notation wise, this looks like this. F of f inverse of x is simply x because f inverse and f cancels out. That's what's happened here. What's the question asking us? What does that f dash dash x mean?
The second derivative of x.
Yeah. So let's do it. We're given cosine squared x. Let's first find the first derivative. What would that be in this case?
Two negative sine x.
So right now we have cos x squared. Okay, this is what we have originally. Need to first use the power rule. Cool.
So you bring the 2 in the front.
Mm-hmm. You're gonna bring the 2 in the front. And what? What's gonna happen for the next 2? Inside bit stays as it is, right? Power 1. What do you multiply this by?
Negative sine x.
Yeah, negative sine x. So that's just the first derivative. Your first derivative, again, you can group them up. It's going to become negative 2 sine x cos x. Then we got to go a level deeper. You got to use a product rule. Okay? You can treat this as your f, and you can treat this as your g. What is the derivative of negative 2 sine x?
Negative 2 cosine x.
Yeah, negative 2 cosine. Again, we're using the product rule, so it's going to be f times g as it is plus f as it is times the derivative of g, which is g prime. What's g prime in this case? G
Negative sine x.
is, yeah, negative sine x. So what do you get? You get negative 2 cos squared x minus 2 sine squared x, like that. And actually, it's going to be plus. Negative and negative becomes plus, and that would be the final answer for this question. Cool? B is a little bit weird because it's asking us to find the derivative. Again, it looks like it's a product rule question because you have two different functions being multiplied. But for B, you need to know a trig identity, which is this: cotangent of x is cos x over sine x. If you don't know this, then you may not be able to do B. Okay? That tan is sine, that's another big trig identity. Tan is sine over cos, and cotangent is just tan flipped upside down. That's why. Cool? All right, so we're gonna rewrite this as cos x times cos x over sine x. So this becomes cos squared x over sine. That's just y. Next, we need to use the quotient rule. Right? So what would be f prime?
You bring the 2 in the front.
Yep. So you bring the 2 in the front. Cos x becomes cos x. What do you multiply this by?
Negative sine x.
Negative sine x. That's just f prime g minus f, and then g prime would just be the derivative of sine x, which is cos x, all over sine squared x, and that's y prime. Cool? Don't know if I want to do the other one. That's okay. We're going to stop here because the other one's going to be pretty long. So in these kind of questions, it's important to know some trig identities. It'll make your life much easier. If not, then yeah, the only other way to do it would be if you remember what the derivative for cotangent of x is, which is a weird one. So yeah. This is just a very simple two-step question. Calculate the slope of the tangent for this function when the x value is 2. Any ideas? Okay, slope of the tangent line, you just find the slope function, which is the derivative, and then you plug the x value in there. That's it. That is it. What's the derivative of this guy? You see 5 to the power of x?
Mm-hmm.
What's the derivative of it? It's pretty easy, okay? Look at this. Y is 5 to the x. We find the derivative, yeah? This is very similar to e to the x. You just write itself, then you multiply this by the ln of the base. And you'd also multiply it by the derivative of the exponent, but the derivative of x is 1, so you can just ignore it. Cool?
Mm-hmm.
Make sense or no?
Yes.
And then the next part, you just plug 2 in there as x. So 5 squared times ln 5, that's going to be 25 ln 5. So this is the answer when you plug this in a calculator. That is it. That's all you have to do. Okay, slope of the tangent. First, you find the derivative, and you plug the x value in there. Wait, what? This page repeats. Look at this. This is so weird. 266, 266. This entire page just like repeats right here. All right, what should we do next? Let's do one of these questions. It says, don't know if you're ready for this though. The absolute extreme values. So these guys, okay, look at the extreme values. For any function, it's like these guys here. See these?
Mm-hmm.
What's common about all those points there?
The slope is 0.
Yeah. So you're gonna find the slope function and set it equal to 0 to find the x values. What's the derivative of this?
You bring the 2 in the front.
Sine x becomes to the power of 1. What do you multiply this by?
Cosine x.
Cosine x. Yeah, there we go. And then you're going to set this equal to 0, okay?
Mm-hmm.
This means either whenever you're multiplying two different things, and if it's equal to 0, it means either the first guy is 0, or it means the second guy is 0. So when is sine x 0? Let's look at this. This is a circle, okay, that has a radius of 1. So that means this point is 1, 0. This point is 0, 1. This point is negative 1, 0. This point is 0, negative 1. On this circle, okay, you see this is 0 degrees. This is 90 degrees. This is 180 degrees. Again, it's going to go up by increments of 90. This one would be 270 degrees. And this one back here would be 360 degrees. The x value of the point determines the cosine. And the y value of the point determines the sine. Now, what do I mean by this? You see here, the x value is 1. Yeah?
Mm-hmm.
What's the angle here? From here to here, what would be the angle? It's just a straight line.
180.
So, no, that was a trick question. It's going to be 0. Okay? We start here. The angle here is 0. So that means cosine of 0 is the x value at that point, 1. And sine of 0 is the x value at that point, 0. Okay?
Mm-hmm.
So we're looking for when sine x is 0. We know that it's going to be at 0. Let's look up here. What's the angle up here? From here to here. It's 90, yeah?
Mm-hmm.
So that means cosine of 90. Cosine is the x value. It's going to be 0. What's sine of 90 going to be? It's the y value at that point.
1.
1, yeah. We're looking for when cosine is 0 as well. Turns out it's at 90. Let's go down here. This angle is 180. From here to here, this is 188 degrees. And pi means 180. So this is as far as you have to go. What's cosine of 180? Remember, it's the x value. At this point, it's the x value.
-1.
-1 is absolutely right. What about sine of 180? It's the y value at that point. It'll be 0.
0.
Yeah. So does -1 help us? Cosine being -1 doesn't help us, but sine being 0 does. So the other answer is 180. So there you go. That's our answer. 0, 180, and 90. When this is the angle, then you're going to get extreme points, which means the slope of the tangent line is going to be 0. Cool?
Mm-hmm.
Should we start from backwards? No. Let me see which one is doable. Most of these are pretty simple. Let's try doing question 6. I don't know if you remember this. This was a while ago, but they've given us a graph. We just need to find the limits. The thing about limits is they only exist if the limit on the left is equals to the limit on the right. Here, let's go one by one. 6a is asking you to find f2. What does that actually mean? What does f2 mean? It means find the y value, okay, when the x value is 2 from the graph. So x value 2 is right here. What's the y value when the x value is 2?
It's 1.
If you look at 2, when the x value is 2, it has 2 different y values. One of them is a closed circle. The other one is an open circle, okay?
Mm-hmm.
Closed circle, open circle. Which one do we use? Closed circle means it's yeah, so you're going to use this one, not this one. Open circle means it's not part of it, okay?
Mm-hmm.
This means when x is less than 2. But this closed circle here, this means x is greater than or equal to 2. If you take this path, you're going to get x is greater than or equal to. But when x is exactly 2, y is exactly 3. So that's going to be the answer here. The second one, it says when x goes to 2 minus, here, this one. X goes to 2 minus means what's the y value to the left of 2, directly to the left of 2. So we're looking at it right here. You see this? This is 2 minus. What's the y value approximately? It's 1. Yeah. The third one, it says find the y value directly to the right. 2 plus means directly to the right of 2, okay? So that we know this is exactly 2, directly to the right of 2 is here. What's the y value? Approximately
3.
3. Okay, the next one. Limit as x approaches 6. The fourth one there. So what's the y value from the left? We don't look at exactly 6. When we're talking about limits, you don't look at the exactly, we don't care about what happens exactly at 6. But we care about the right and the left sides. Look at 6. from the left side, yeah, here, what's the y value?
2.
2. So this is called 6 minus is 2. What about 6 plus to the right of 6?
4.
To the right of 6. No, 4 is exactly. 4 would be f of 6. 4 is the y value when the x value is exactly 6. Okay?
Mhm.
Right of 6 means right here. What's the y value?
It's also 2.
So does the limit exist? Both limits on each side are the same. If the limit on the left and right hand side are the same, we don't care about what happens exactly at that point. We're strictly concerned with the left and right side. Then yes, the limit exists, okay?
Mm-hmm.
6 minus and 6 plus, they're both 2's. That means when x is 6, the limit is going to be 2. Okay, the fourth one is not asking you for f of 6. It's asking you for the limit. For that, you need to look at the left and right hands and see if they're equal. Using this idea, we already have the numbers up there. Tell me, does the limit at 2 exist? In other words, is the left limit and the right limit at 2 the same?
No.
No, they're not. The left, we got a 1 on the second question. And the third one there from the right, we got a 3. The fact that these two limits are not equal means the limit does not exist, okay? If it asked you for a limit of 2 and when x goes to 2, that does not exist because left and right are not equal. What about B? At 4, it's asking us now. Look at to the left of 4 and look at to the right of 4. Are they the same?
No.
No. Tell me, left side, what's the limit? Could be a trick question, right? Here, I'll tell you. Left side at 4, we're looking at 4. You look here, okay? Whatever the function closest to it
Mhm.
is. It's positive infinity. 4 minus means to the left of 4, it's positive infinity. What about 4 plus to the right of 4? What's the limit?
Negative infinity.
Negative infinity, right? And these two are not equal. This is called an infinite discontinuity is what this is called. There's an asymptote and then, yeah, kind of splits the graph in half. All right. That's it for this question. Okay, so now here they have not given us a graph, but they have given us the equation. Do you need a graph for this? Probably it'll help you. Probably not necessary, but I would like you to see it. We can quickly graph, again, these are linear functions, right? They're super simple. I'm gonna first graph this negative x plus 5. That means the y-intercept is a 5, right? 1, 2, 3, 4, 5. What's the slope for this one?
-1.
-1. So that means for every 1 unit you go to the right, you go 1 unit down, yeah? This is gonna be your second point. So that's when the x value is 1. This is when the x value is 2. When is this function active? Look at this. It only exists when the x value is greater than 2, yeah?
Mm-hmm.
This function does not, it's not gonna be like this. It's not gonna exist in the left quadrant because x has to be greater than or equal to 2. At 2, if I just built this, right, go 1 unit down, 1 unit across, there you go. That's my starting point right there. Is it inclusive or exclusive at 2, this function?
Exclusive.
Exclusive. Is that an open circle or a closed circle?
Open.
Open circle like that. And it's going down, okay? So that's gonna be our first function right there. That makes sense?
Mm-hmm.
So this is x is greater than 2. This is done. Now let's look at the middle one. 2x plus 1. That function only exists at a specific point. Okay? When x is exactly 2. For this function, if x is exactly 2, what's the y value? Just look at this one. If x is 2, what's the y value? The function is 2x plus 1. Just plug in x as 2. Okay?
It's 5.
It's 5. So when x is exactly 2, the y value is exactly 5. Is that a closed circle or an open circle?
Close.
Closed circle, yeah. So when x is 2, y is exactly 5 with a closed circle. You can already see that there's a jump here, right? But we
Mm-hmm.
don't care about this point. We want to look at the right side of this. Sorry, the left side of this. The third one is x squared plus 1. Now, when the x value is 2 for this function, what's the y value? Just plug 2 in there. You'll see that it's 5, okay? For this one, if you plug x as 2, you'll get a 5. Do you agree?
Mm-hmm.
Is that an open circle or a closed circle? Look at this.
Open.
Open circle. That means the third function, when the x value is 2, the y value is 5, but that one has an open circle. And what does x squared plus 1 look like? It looks like this. I'm just going to plug values for to graph that one. When the x value is 1, the y value will be 2. Just plug 1 in there. So the next point is 1, 2 down here. And let's plug one more. When the x value is 0, what's the y value? For this function, if the x value is 0, what's the y value?
It's 1.
It's 1. So there. So to graph that, it's going to look something like this. And this is an even function because the exponent is 2. It's going to be symmetrical. We know quadratic, we've graphed this before. It's going to go right back up there. All right. Now finally, we can answer the question. Where is this function discontinuous? In other words, where does it jump? Are there any jumps?
Yes.
Where? At which x value?
When x is 2.
Yeah, when x is 2, it's discontinuous. Does the limit exist at 2? Look at the right side. What's the y value at 2 of 2, the right side of 2, and the left side at 2?
The limit doesn't exist.
Yeah, it does not exist. What's the limit on the right side? What's the limit? 2 plus. Let's say 3, okay? You see right here? 2 plus means that, just directly to the right of that open circle. And the y value is 3. What's the limit at 2 minus?
5.
5, exactly. Since these two limits, we don't care about exactly what happens at this middle guy. Actually, for these questions, you can even ignore this. This doesn't quite help. You want to look at the left and the right and see if the limit exists. In this case, it no exists. And that's it. Right, this one. Determine the slope of the tangent. Okay, so they've given us a quadratic function, and the point, they've not given us an x value here, but we can find the x value because it's gonna intersect y equals 3x. All right, so we need to find the point of intersection between the curve, the quadratic, and the straight line y equals 3x. Do you remember how to find the point of intersection? You just set them equals to each other. That's it. And then you solve for x. Okay? Set them equals to each other. You'll do that for any function, not only for linear quadratic, any function. If they ask you for the point of intersection, just make them equal to one another. So here we have x squared plus 9x plus 9, and this is equals to 3x. So now we have a quadratic equation. How do you solve this for x?
You subtract 9.
No. So for a quadratic, for degree 2 or up, you want to bring everything to the same side. Make the other side equal to 0. So you don't subtract 9. You're going to subtract 3x because you need one side to be equals to 0. Okay? So you get x squared plus 6x plus 9 equals 0. Now we have a quadratic trinomial. You're doing this in school right now. How do you factor this?
You use man.
You use man. What are the numbers? So they add up to 6 and they multiply to 9. What are the numbers?
3 and 3.
Yeah, 3 and 3. So this becomes x plus 3. Because the leading coefficient is 1. Once you have your numbers, it's just going to be like this. And you can rewrite that as x plus 3 whole squared equals 0. Square root both sides, you get x plus 3 equals to the square root of 0, which is still a 0. And finally, x is negative 3. Cool? So we know what our x value is. From here, it's simple. Slope of the tangent is simply, you first find y prime, and then you plug the x value in there. What's going to be y prime here?
2x plus 9.
2x plus 9 is correct. And then you're finally going to plug the x value in there. It's going to be 2 times negative 3 plus 9. It's going to be negative 6 plus 9, positive 3. So that's going to be the slope. Cool? Graphically, if you would like, these are pretty simple. Like linear and quadratic are super simple to graph. Y equals to 3x. So you start here. For every 3 units you go up, you go 1 unit to the right. Again, it looks something like this, approximately. This is y equals 3x. X squared plus 9x plus 9. We've already factored it. Okay. We already factored it. It would look like at negative 3, there's a turning point. It's going to come up and it's going to go. What did we get? Actually, no. X plus 3 whole squared. It's going to intersect the line at y equals to 3x. Okay, cool. So it's going to look something like this. It's only going to meet it once, though. It's going to meet it once at -3. So they're going to touch there gently, and it's going to go away. Cool?
Mm-hmm.
And if you draw a tangent line at that point, we know the slope of the tangent line is going to be 3. So therefore, if you where they intersect, right? We draw a tangent line, it's going to be 3. Make sense?
Mm-hmm.
You want to do a really quick question here? Look at this. It's very simple. It's simple because it's not like e to the x or sine x or chain rule or anything. It's just a polynomial. It's just a quadratic. What's going to be the derivative of this?
4t plus 6.
4t plus 6. A is done in the back, easy. B, determine the rate of change when the population in 1990. So how many years has passed since 1980?
10.
Till 10. So for B, you'll just find p prime of 10. 4 times 10 plus 6. What is this? 46. Is it in thousands? No, it's not. It's just 46. So that means in 1990, the population of this town was increasing by 46 people per year. So 46 new people were coming in every year in 1990. Okay.
Mm-hmm.
At the beginning of what year was the rate of change of population 110 people per year? So now they've given us the slope, right? They've given us this value, the rate of change. So that's 110. And they're asking you for the time. So remember, this is the slope. Rate of change is the slope. Do you set this equals to 4t plus 6? Or do you set this equals to the original function? Do you remember this? This is the rate of change, 110 people per year. You're going to set it
Do
equal
the second one.
to slope function. Yeah, slope equals slope, not the main thing. You do this, you get 4t equals to 104. And t will be what? 26. There you go. So after 26 years from 1980, that means in 2006, the rate of change will be 110 people per year. Okay.
Mm-hmm.
Alrighty then. And that's it for us as well for today.
Okay, thank you.
See ya.